Alright, getting started in a second. Looking up backup sources, checking audio levels. Dun, 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 dun. Alright, onto the workspace. Come on, where's my live playlist? Alright, YouTube. Gone live. Should be live. Should be playing live. And I got crap. Why do I got crap? Don't need it. My Python. It's like YouTube really, oh, there we go, doesn't want you to know. There we go. Okay, cool. Alright, much better. Like how you sound, what you look like, where things are going. This is one of those things where it's like, okay, I'm live, I know I'm live, I need to be able to see it in case somebody talks to me. So I've got to display it on my phone, check out the chat, because, you know, it's the whole stream like nobody's watching, because most likely a lot of people are not watching. Anyway, so today, what I've got is a mini laser pointer. Got it from Adafruit. And so I want to attach it to the motor board for my big time AlphaBot. What I'm also looking forward to is I'm going to put some holes in the top of the big time AlphaBot so that I can mount stuff and get to it a little bit easier. Because right now the problem is the Arduino just sits right on top of it, and there's nothing actually holding the Raspberry Pi sits right on top of it, but nothing holding it in place. So I want to add some basically screw holes for make it a little bit easier to mount to. Also, the laser has a little holder, so I'd like to have some holes for it as well, so I can have it offset just a little bit and not actually sit directly on the so if I make holes for the Raspberry Pi over here, holes for the laser over here, we should make it pretty nice. Now for sizing, I luckily have another Raspberry Pi just sitting right here. So what I'm doing is I'm just going to mark on the plastic where the holes are. Now I picked a drill bit, but it should go smaller. Should also make sure that the oil is plugged in. It is plugged in. Alright, that's better. My cat's looking a little bit freaked out. She's like, what's going on? Python. This is perfectly normal. So she's skulking by the door, so I gotta open it so she can get out if she wants. One of my bad habits. Well, not really a bad habit. A thing I generally have to work through is I don't like modifying things. I don't like making changes to my devices because it seems like, well, they're set up a certain way, so I shouldn't need to change them. But I also need to get over myself and learn to make changes to the things that I can. Once watches, I lose a finger. So next, I'm going to double up on the holes here. There we go. The reason I doubled up on the holes is in case I use tie wraps instead of screws, I can actually just use the double holes to loop through. Should make this a little bit easier. Scratch off some bits here, both inside and outside. I think the technical term is actually called deburring the holes. And this is also 3D printed material, so it's fairly soft and easy to get through. Just ABS plastic. And of course, I'm wearing glasses for safety. You too should wear glasses for safety. Alright, perfect. Excellent. Mounting platform achieved. So So now a little bit of house cleaning, and then now that I've drilled holes and things sitting here on my table, got the black leftovers everywhere. These little scraps of plastic. One of the real problems with the Raspberry Pi platform is the holes, I think, are M2.5. And most everything I have is either M2 or M3, not 2.5. So we'll see what we can do. Of course, if I'd have been really smart, I would have tested that with my drill bit. So otherwise I'm stuck to using these super duper long ones, which, while they'll fit, won't be super great. Super great. Green, super green. Fifth Element reference, if you didn't know. Yeah. But the other problem is none of them are long enough to actually go through the plastic itself, so I am actually going to have to use tie wraps. For great justice. And of course, two of my holes are taken up with the stands that I'm using for the mounting bracket for the motor shield. So I'm stuck to using that. But even so, this will give me tension on this side because the posts actually descend below the edge of the Raspberry Pi, and on this side I will just tie wrap it. Tie wraps for life. Okay, now of course it's difficult to get in. There we go. Nice. And of course I forgot the one thing underneath when I was taping this down. The problem was that it was very noisy, and what I forgot were the bits of foam that I had underneath the Raspberry Pi. The reason I have foam underneath it is to kind of isolate the noise, because the microphone for picking up me speaking to the people listening through the big Alphabot is actually on the Raspberry Pi itself. Of course, this makes it all stick up. Which is just annoying. Well, this will still work. Okay, looks like these holes are just a little off. I got them both parallel to each other, but 2 millimeters off the board, like off the hole center. No, I should have made sure to do that with this one. So one of the things I'm trying to do is keep the ties going out, so it's mostly flat on the inside, so that nothing prevents the motor board from actually attaching to the top of the thing, to the top of the Raspberry Pi. So now, a little bit of tape is super useful, especially for identifying the wires. Of course, it also helps to have something to write with. Permanent Sharpie, and this is power. And so I'm going to label these 1, 2, 3, 4. The black and white, it's black and red for power and ground, obviously, are pretty easy to remember, but the positioning is not necessarily easy to remember, so that's where I want to make sure that they go back into the same holes. The code for these guys also calls for the specific ports to be triggered for left, right, forward, back, and then turning, because each wheel is motorized independently, so each one gets a separate set of commands, but all of the commands have to know, well, if I'm turning left or right, I'm turning on these two motors or off these two, or they're going forward in this direction or backwards in this direction. And part of this is because I'm going to solder the laser onto the board here, or at least the wires. What I'm probably going to do is multiple wires, 2 for the 2 to attach directly to the motor board, to the GPIO pin, and then 2 more, and then to the laser itself. So. Sorry, this is not exciting YouTubing here, and it is freaking hot. So now that my wife was working in the other room. 1, 2, 3, 4. I know one of the original inventors for this said not to use terminals, because what can happen is the wires will essentially become loose at the terminal point, at the terminal block, and become detached. But hopefully, since I've got the pi fixed in relation to most of the wires, that I haven't seen that as a major problem. It also hasn't been... What? Just... Oh, shoot. Oh, shoot. Well, I said that it wasn't a major problem. I just unscrewed the entirety of that terminal block, and it came out. Which is interesting. So, that's the little wire piece. So that goes inside one of these guys. It's the piece in there, and then the little screw on top is what holds it in place. Of course, now you can actually see it since I'm holding it up further. There we go. It'd help if the screensaver wasn't kicked on my computer, so let me now try and track down that little screw, or else I've got to do a larger soldering job of unsoldering this terminal block. How did that even get out of there? I'm guessing it clips on the front. So, you a piece of a terminal block, or are you just some trash on my floor? Take me away, cell phone flashlight. Well, what was going to be a fun project now has turned into a larger project. Alright, he's dead, Jim. Alright, so I had to unsolder a terminal block. Luckily it's right on the end, so it should be easy enough to melt the solder, pop it off. Or I have another board entirely sitting right here. Yeah, I'll keep using this one. I don't want to do this to multiple ones sitting here fiddling around. Alright, so anyway, back to the laser. Little laser. What I need to see this is on here. So my wires for both Raspberry Pi power are coming out here, all the motor controls, so they should be coming down the center, which means this wire for the laser is got to reach over here. It probably needs to be just a hair longer. So let's attach this and then affix the laser. Affix the laser now because it's not going to hurt anything to get it in place. Really? So I probably should have used a larger bore or a larger die screw, but that's actually going to hold really nicely. Probably should have put a washer on it. And interestingly enough, so YouTube just stopped on my phone because I unplugged the headphones while I was looking for the bit. So what that probably means is that YouTube is actually detecting whether or not your headphones are plugged in and blanking the screen whether or not your headphones are plugged in. I'm actually going to angle this way down because my expectation is that my cats are going to play with it, in addition to people from the internet just triggering it on and off. And so I don't want well, actually I can do that, and so I don't want it getting in their eyes, obviously. So angle it a little bit forward and just aim it down. So now, as I'm looking at it, what I could do, as opposed to all my other problems with terminal blocks, is actually use another terminal block for this, specifically. Oh, really? The spacing on the terminal block header is just wider than the proto board space on the Adafruit motor controller here. That's funny. Funny as in interesting funny, not funny as in haha funny. That's kind of annoying. Alright, well, I'm just going to do some wire and solder it right to the wire. Alright, so solder these wires to other wires to make them longer. Unsolder and replace the motor board settings here. All the the while trying not to bend the board or break it. What I'm also worried about is that the screws are going to come down too far and hit the battery on the inside, especially this one. This one should be far enough forward. This guy, though, is going to be possibly banging into the top of it, and I don't have a shorter one to replace it with. So. Okay. So first things first, let me desolder this guy and replace it with that one. I hate it when I have something out and then I put it away. There is a tool called a solder sucker that is made so that when you melt the solder, you can just pull it right off of the board. But I do not have one handy. I do not know what I did with it. Alright, turn on the Hako. Actually, where is my solder wick? So there's another tool called solder wick, of which I also don't see any of my solder wick. As you solder, the solder wick basically will use capillary action to suck all of the solder up into itself and not leave it on the board. So let me see what I have done with that, because it'll make this a lot easier. It's one of those days when I wish I was way more organized than I actually am. Yep, here we go. You can tell the solder sucker was developed by an engineer because it's got the name that an engineer would give it. All it is basically a spring-loaded mechanism. You pop that down and it compresses the air, so when you push the button it creates a vacuum, sucks all the solder up into the tube, and the low pressure also means that it cools it very fast, and as it cools it, it just basically turns into solid solder at that point. You just got to fish it out of the tube. You just scrape it out. So, in this case, I want to touch the bottom of it. It's going to melt. It goes loose. And I just pop. And most of the solder's out of there. You can actually see on the bottom the little tendrils of solder as they were sucked out of the, or sucked away from the tube, and they just kind of sit there. One down. don't know if there's a recommended number of times to do this or anything like that. What I really worry is that if I link these two together, oh really? Well, maybe this is a good case against terminal blocks. When you break the block, you just screwed yourself. Oh, there we go. Of course, I'm also burning my fingers slightly. Don't do this at home, kids. Micro-sized flathead to use as a lever to pop this bad boy up from the center, and so I'm not burning the crap out of myself anymore. There we go. This is part of engineering and soldering that they don't tell you about. Like, hey, it's all broken. So now we install a new terminal block. It is a tight fit because now the holes still have some residual solder in them, so they're harder to get to. They're harder to push the studs through. Turn the end just a little bit. Alright, looks good. And now I'm back where I started. Further. Solder sucker back where it's easy to find. Needle those pliers the same way. And wire cutters. I'm going to be incredibly unfashionable and use red and green instead of red and black, so my wires will not match, unfortunately. Come on, YouTube, keep up. Okay. Make sure I get about the same length. Pull in a little closer than I was. And get some chisel out of the way. Must learn to clean effectively. I'm going to tin the ends of both of these wires, which is just heating the wire up and applying a little bit of solder to the end of it. This makes it so that the solder will adhere. I'll do both of these wires first. So I did red. Touch shorter. Now I am doing something kind of bad in this, and I'll let you know. The wires that are on the end of the laser are actually stranded wire, which means that it's a bunch of small wires all stranded together and wrapped and braided. These guys are actually solid core single wire, and you really shouldn't mix them together. You can, but you shouldn't. I'm not sure exactly why not. It's just one of those things where it's like, oh, you shouldn't do that. I think it has to do with because you're changing the conductivity of the wire, or the way the wire can interact. It can cause problems. Also, what I'll probably do after I have soldered these together is put some heat shrink tubing on it so that the wires will okay, you need to come back. Not necessarily have the stress of trying to be connected at the same time as bearing current, and it gives the insulation to the two wires. Oh, come on, stick. I can feel the heat in my fingers because it's burning them, so I know that part's working. I can see the wire melting. Or the dielectric insulator is what it's actually called. It also changes the stiffness of the wire, switching from braided to solid. Obviously, you can see the braided wire moves much easier, but the solid's much thicker and rigid. So, yeah, heat shrink tubing will need to be applied to these guys. Not a problem, I've got a bunch of it, so. The problem with sling worm lamps is they never seem to work, like, for a while. Wish there were a better solution to that. It's a stupid problem, but, you know. Alright, so tin the end of my solder tip. One wire, heat up. Okay. Soldering's taught me to do more things with less fingers. And that is probably the worst solder joint I've ever done. Let me redo that. Much better. Okay. One of the things I do with heat shrink tubing is you can use a hot air gun or just the barrel of the soldering iron itself. You don't want to use the tip because this does leave a residue, but this will get it sealed and shrunk down effectively the same way, because it's the temperature of the soldering iron essentially, but not as hot and not as concentrated as on the tip. Looks good, looks good. And number 2. Actually, it's probably a little bit big for this heat shrink tubing itself. I probably should have started with a smaller piece of it, as in diameter piece, not length. Okay. I will have to try to figure out how to make these YouTube videos even more interesting than they already are. Somebody soldering I don't think is actually too interesting, but alright, we're good on that. So now let's attach it to the board. All I really need is ground and a GPIO pin, So let me use 17 and where's my ground row? So on the Adafruit boards, which is very nice, this bottom row of pins here is the ground row. So I can go one there and then one there. And that should effectively give it my ground and my data pin. So there'll be one up there. Plug it in and 17 there. Plug it in. Right. So you may or may not have noticed when I stuck the wire in, I bent it sideways. That helps hold the wire in the hole. Ideally, you'd want to do this early in the process before you installed the header block, so it'd be easier to solder in that hole. But because I'm doing it after I've already built the board, so touch the wire with the tip, add some solder. Looks good. We're in on 17. Add some solder. Make sure I didn't screw that up. Looks good. Alright, clip it. Always clip off the little excess bits. Alright, fantastic. I think we can take the soldering iron offline now. Should still be good. These guys are dirt. Come on. Alright. So the wires kind of go up, but because of the stiffness of the solid core wires, but I'm okay with that because all the motor wires have to come underneath along here, and they power for the Raspberry Pi itself. So, alright, heatsink tubing back in the box. Third hand back. Alright, you're pretty fixed. I'm actually going to pull this up and angle it more inward. So I'm angling this slightly because I want what I'll have to do is make sure that the laser pointer is within view of the camera, which is coming right out the front. So I want them at least slightly aligned similarly. Here's the camera cord and the speaker. Oh, I should have had a spot for the speaker. Let's check our fit. Oh, we're good. Alright, length of the screws was not a problem. Got clearance in there. Alright, great. So, back to wiring up the power for the motors, or wiring up the motors themselves. In which case, let me actually take the laser off, drop it off to the side. first since it's furthest away. Should really helmet mount the USB cam because I know you guys can't really see what I'm doing here other than, oh, it looks to be like he's tightening wires. How about that? Sorry. I will say one danger of the using the terminal blocks is that you can tighten down on the wire too much and actually just cut the wire with the pressure of the terminal block itself. Of course, now that I've got this little laser mount here too, I can also block some of my light and the ability to get my hands in there. Actually, if we're going to make a design change, it would be that this, a microphone for the USB, for the basically USB microphone, would actually be mounted on a flexible tube, something like this, so it could stick up from the body of the thing, or even the camera actually sticking up from the body would be interesting. Mainly because when you are doing that, would get it off of the, basically as it's fixed, it's really close to the motors and picks up a lot of the background noise from them, but also because it makes it so that you're I think one of the things you miss with, you know, what you're when remote controlling or remote ROVing, anything like this, you don't know how big it is, you don't know where your presence is. When you're, as a human, basically you've grown up with your arms and your legs and whatever, or most of you have anyway, and you know from the perspective of your nose how your hand moves. Your brain is doing those interpretations for you, so you don't have to think about it logically. Like, you're not making that interpretation of where's my muscle going now, where is it, you know, how much pressure do I have to apply, that kind of thing. It's just natural. It happens. When you're ROVing a robot, you don't know where, so how wide am I? Can I fit through this hole? There's none of that sensory feedback exists for you. Alright, why is that ground wire not attaching well? think one of these ground wires is not going to... It's giving me issues with its port. Last one. Okay, great. So let's attach the Pi power connection as well. It actually goes underneath all the power cords, the motor power, the motor controller. That's okay. Of course, huge ball of tape from where I had it attached before. This is the camera itself. So what I'd like to do with it is have it come up on the outside edge here, plug in. This I will use a large zip tie for. And of course I have the regular speaker for its audio. And of course I put the laser pointer in, there we go. Actually, I should route the speaker wire out on the outside edge too, but we'll see how it goes. This is about rapid prototyping, not rapid working. Because ideally I'd actually want an on-off switch as well for the whole thing, especially for the laser pointer. I could easily see, get the laser pointer going, and all of a sudden we'll have problems. Alright, so we're mostly live. And what this will do is this will also start streaming soon. So we're going back up on the block for workbenching. And so I can prototype and make sure pin 17 is working. Alright, I'll probably include that as a separate stream, actually. And bring back the computer. There we go. Putty into my, well, y'all don't need to see all my stuff. Okay. what I need to know is GPIO Python. Because all I really need to do is make sure I can turn on port 17. Alright, GPIO out. Sorry, I've got you up on blocks to fix you. I'm adding lasers. Dude. Set up channel GPIO. That's more than I want. So what that means is this needs to be a list. Alright, Python, what the hell are you doing? Channel sync is invalid. Okay, so So the setMode.board basically tells set up pin 17 as out. Out. Alright, Raspberry Python. Using BC, so we'll switch it to BCM and see if it works. Okay. Because I highlighted the space in front of the line, I considered it, so let's do that. Okay, so setting it to BCM worked. Alright, let's see if we can set it high on low. Output and oh, that did it. It turned on the laser. I turned it off. Ah. Let me see if I can get you guys. To see the webcam also. Okay, so we got the webcam on, off, on. It's not super bright. Oh, that's interesting. You can't see it on the webcam. It'd help if it were actually. So I gotta aim this lower. There we go. Awesome. So this sets it up about out here. So about 6 inches in front of it. So well, a decimeter. All right, I'm happy with that. Okay, so next, what that means is we need to get to our source code for the bottom thing here. Okay. Really? You're on blocks, so you can't move. But if you haven't seen it yet, while I'm run my robot.com. So how do you say my robot is in development mode? Nice. So y'all can see me on the stream, streaming you guys on the other window. Okay. Alright, what I need. You're on blocks, you can't move.
On blocks for now.
Okay. So what I need
Why?
is I'm giving you a laser. I need the custom code to run the controller. Here I can show you the wow. All right. Docks, I need docks. Okay. Okay. Check my JSON syntax. button panel label, lasers.
Hello.
Hello. Buttons, label, left, command. This.
Can we use it, please?
Saved, got it. Alright.
Pay attention to me.
I am paying attention to you. I'm giving you lasers.
I miss you.
Alright, so.
And your beard.
I never had a beard.
Am I broken?
No, I guess I can start you up because. So what I've added is you now have a laser on the side of you that will fire off, but I'm just adding the controller code at the same time.
Why is
So
everything so quiet?
there we go.
Thank you.
You're welcome. Robot incoming.
Test. Hello, humans.
I'm still here.
Yes, the mic volume is just low.
The mic volume is low. Okay.
No, that was a different part.
You can hear me.
Thanks, you must have no TTS.
As long as you can hear me, okay. Yeah, front motor.
What's your name, friend?
So I'm Donald.
Carl?
Yes. Handle command.
Hi, Carl.
Hello. So how are you tonight?
How are you feeling today, Carl?
I'm good.
Good. We have a laser. Do you accept the robot race as your new overlords? Activating laser. Too much time in controls. You're not the guy who works at Parallax, are you? Parallax. I'll take that as a no.
I'm customizing my UI, so. Let's see what we get.
Laser's underwhelming.
Well, it's not on yet because you wanted to drive around before I got the laser on. Okay.
to connect get installed test laser. Might not be located.
You're gonna find out.
What? Audio is choppy.
On the YouTube stream, you guys are missing is this. This is the actual feed from the robot. Remove this one. Oh. So I got the laser command in there. Of course, you can see it when the audio picks up. But what's not happening is I'm not getting the fire command. So it's not handling it when it comes in. I will say I did not write any of the code for this. But what I want so I added this function, so handle laser. I choose camel case, so it's cool. So I want to look at, what is this function? Run motor 0. Handle start reverse SSH process, handle reverse on handle command. I can hear it going in the background as the robot kicks off. He's wandering around the room. I wonder if you guys can hear me now, though. Okay, I do see some audio coming in. Okay, good. So I see the handle functions, but what I'm looking for is what's actually calling the handle functions. Basically, there should be another function that calls each of the handlers, basically, and says, all right, for this type of argument received from the server I/O, which actually should be, all right. Handle command. So on handle command, start new, handle command, args. Handle underscore command, so define handle command. So this is the thread that actually handles the commands when they come in. Alright, driving speed, if handling command, return. Command is true.
Hi.
Hello. I'm trying to figure out how your controller code works. And why the tab stops aren't set up correctly. Call it. Fire laser. Ah. Now I'm going to change this. So what I'm going to change is the fact that the controller sends all logging to dev null. I actually want to change that around to let's write it to a local script.
You know, you complain about this. Oh, it is moldy.
Okay.
But you don't do anything about it.
Carl.
Yes. I got fussed at for not having my
What's the state of the
Not throwing away old food. But, you know, it's the pot calling the kettle black.
Yeah.
You should have seen all those dishes I had in the sink.
Oh, I saw them actually.
Actually, we need to take that bag out because it smells really bad.
Okay. Ah, damn it. My VI foo is not
I'm going to be helping with Henry in a little bit, so.
Okay.
Carl, please.
Did you jam yourself into the wall? Here you go. And we're going to lose the live feed in 2 seconds. Oh, really? So I've got this Raspberry Pi actually hooked up so that it gets a deep dynamic address. or while it does DHCP, it's got its MAC address is actually assigned to a static address. So it'll still hit the DHCP server for an IP address, but that IP address is fixed. So I can just restart the Connect to get back into it almost immediately. The big thing that I'm doing here is I've got the controller interface so that it'll fire the lasers, but what's not happening is I don't know what command. It should be the fire laser command as I configured in the JSON. That should be.
I'm back.
All right, great.
Thanks, Carl.
It's actually Donald, but I think it doesn't come through really well. Let's see, restart session.
Carl is the man.
You're back in business.
Hashtag Carl for president.
And now I should have one files. Oh, come on.
I'm still missing buttons for movement, however.
Does it need movement buttons? Or is it only the arrow keys? Oh, I see. So using the custom panel removes the... So setting up a custom UI also removes the custom or the movement control buttons? Okay. Alright, well, I'm calling the YouTube video for now, and I'll stop it here since I've gone on long enough. And I'm going to keep working on this, and talk to you guys later. Subscribe so that I know that you actually like this, or if it's useful. Or comment, or tell me if you want to see something else. Alright.